In example 1, we have 2, this is the left side, 2 to the power of 3x minus 4 equal 2 to the power of x plus 6. Since the bases are the same on the left side and then the right side, what we're going to do is we're going to set the exponent from the left, 3x minus 4, equal to the exponent on the right, so x plus 6. So I'm going to do this step by step. Say I want the x on the left side, so I'm going to subtract x on both sides. So we're going to have 2x minus 4 equal plus 6, a positive 6. Now say I want the number on the other side. Since I got the variables on the left side, I'm going to cancel out the 4. Now I have 2x equal, these will cancel out, and then we're going to have 10 on the left, on the right. Then we're going to divide to get x by itself, so therefore x equals to 5. So when we're solving, that's basically where you stop for this solution. Now, if you really want to check if it's correct, all you gotta do is just plug it in to x. So I'm going to write it out. 2 to the power of 3 times 5 minus 4 equal 2 to the power of, so 2 to the power of 5 plus 6. So if I were to work out the left side, I get 2 to the power of 15 minus 4 equal, and then on the right side, it'd be 2, 5 plus 6 is 11. Now on the left side, 15 minus 4 is 11, and I bring down the right side, it works. 2 to 11 power is the same as 2 to 11 power on the right. So this is our correct solution. In this next example, so what we're going to do is we're going to review and tie in to when we're solving for log expression. So when it comes to log and exponential, here we have it in an exponential form. Say that you're trying to figure out 2 to the power of x equals 16, and you're trying to figure out what is x. So 2 to what exponent will give you 16? So what we did before is that we convert into same base. So I haven't done anything to the left side. What I'm going to do is convert 16 into a small base of 2. And then if I review back from memory, 2 to the power of 4 will give you 16. So when we have the same base, we set the exponents equal to each other. So x equals 4. Now, this answer is only for this example. Now again, I'm just reviewing to tie in to what we're going to do over here. Now for the real example, we have 2 to the power of 5x plus 1 equal 16 to the power of x plus 3. Now as you can see, the bases are different. So what we're going to do is convert into same base. So as you can see, 2 right here and 16 right here. So what we did was we're going to convert to a smaller base of 2, and then as you can see, 16 is the same as 2 to the 4th power. So I'm going to do the same thing right here. I'm going to write it over here. 2 to the power of 5x plus 1 equal, and I'm going to convert 16 into the smaller base which we did before. So 2 to the power of 4. Now when that happens, I'm going to bring this, the original exponent that was in the example or in the original problem, I'll put it next to the new exponent, the 4, x plus 3. So I converted 16 right here, both 16, into a small base 2 to the power of 4. Now what's different in this example, I included the exponent on the right side, x plus 3, because it was in the original problem, and put it next to the new exponent 4. So now, once we have the bases on the left and on the right the same, all I'm going to do is going to set the exponents on the left equal to the exponent on the right. So 5x plus 1 equal 4 times x plus 3. And then when we have something of a number, or even including a negative, we are going to distribute the 4 to everything that's inside the parenthesis. So, I haven't done anything to the left side, so I'm going to bring it down. 5x plus 1 equal, then I'm going to distribute the 4 to everything inside, so 4 times x is 4x. 4 times positive 3 will be plus 12. Alright, now what we're going to do is going to solve just like we did in Algebra 1, Geometry, Algebra 2, multi-step equation. So say I want my x's on the left side. So I'm going to cancel out the 4x, and then since I did it on the right side, I'm going to do it on the left side. And I'm going to do it step by step, easy to follow. So 5x minus 4x would just be x. I bring down the plus 1 equal 4x minus 4x will cancel out, so I'm going to bring down the plus 12. Now I'm writing the plus 12 to remind myself that's a positive. Now I'm going to bring it to this side since I ran out of room. So x plus 1 equals to 12. I got it from here. Now I want to solve for x, so I'm going to subtract 1 on the left. Since I did it on the left, I got to do it on the right side. So I didn't do anything to the x, so I'll bring it down. Positive 1 minus 1 will cancel out. And then 12 minus 1 will be 11. So our answer will be x equal 11. And then that's all we have to do when we're solving for exponential function one-to-one property. Now if you want to check if it's correct, and I highly suggest you check it, all you gotta do is plug it in to the original function and then work it out and see if it's the same. Now, if you want to check if it's the same, I highly suggest you use the one where you change to same base. Okay? In this example, we have 27 to the power of x minus 1 equal 3 to the power of 7x plus 2. Now in this example, we have different bases, and we have a higher base on the left side. So what we're going to do is change in the same base. Now what's common between 27 and 3 is that the lower base is 3. So that means the one on the right will stay the same. Based from memory, based from review of power of exponents, 27 can be changed into a smaller base of 3, and 3 to the third power will make 27. So again, 3 to the third power is the same as 27. Since I wrote out the new exponent, I'm going to bring down this. So, parenthesis, x minus 1, close parenthesis. Now continue from there. I see that the base on the left is the same as the base on the right, so therefore I'm going to write the left exponent 3 times x minus 1 equal 7x plus 2. Now I kept my parenthesis on the left exponent because there's a coefficient outside. Now the one on the right, I didn't keep the parentheses because there was no number out here. So when there's no number, no negatives, you can get rid of the parentheses from the exponent. But when there's a number outside the parentheses, when there's a negative, keep the parentheses until you have both exponents equal to each other. Now, once that happens, once the exponents are equal to each other, then next is we're going to distribute the number that's outside the parentheses. So everything inside the parentheses. So 3 times x is 3x. And then 3 times -1 is -3 equal 7x plus 2. Alright, now it's another multi-step equation. So what I'm going to do is I'm going to get all the x's to the left side. So I'm going to cancel out the 7x from the right side and then do the same thing on the left. So minus 7x. So 3x minus 7x will be negative 4x. I'll bring down to minus 3. 7x minus 7x will cancel out, so I'm not going to worry about that. I'll bring down to plus 2. Alright, now I got all my variables on the left side. I'm going to have my numbers on the right side. So I'm going to cancel out the minus 3 with plus 3. Since I did it on the left side, I'm going to do it on the right side. Plus 3. So I'll bring down to negative 4x. Minus 3 plus 3 will cancel out. And then on the right side is 5. Now once I get x variables on the left and then numbers on the right, I want to get x by itself, so I'm going to divide by negative 4. Divide by negative 4. So now we have x equal negative 5/4. So in here, our answer is a fraction, which is okay, as long as we did the whole work correctly. So our final answer is x equal negative 5/4.